Hello everybody and welcome back to the Educalysis channel, the channel where we educate and analyze a whole bunch of different topics I think are interesting. Today we're going to be talking about traveling in space. Now, as you know, I'm a huge nerd and research a fair amount about space. Well, this video will be all about traveling through space, problems that we'd encounter if we tried to do this, and impossible solutions to those problems. If you enjoy this video, please share it with as many people as you can, and now let's get into the video. This first section will be all about how would we travel through space. As most people know, space is a vacuum, so it doesn't contain any air or any breathable oxygen that we can take in. This requires us to build ships to launch us at such a speed that it can send us into space, orbit, or even the moon. There are obviously more reasons than just air and oxygen, like actual travel, but you know what I'm getting at. Now, even though that there is that fact, scientists have still been able to send satellites all the way past the solar system, like the Voyager 2. The big problem with travel is that a lot of the places that we'd like to travel, which is past our solar system, are light years and light years away. If we were to try and travel to the closest star that isn't our own sun, we'd be traveling to Proxima Centauri, which is 4 light years away. A light year, for anyone that doesn't know, is how far light actually travels in a whole year. To make the average 150-pound human go at 99.99% of the speed of light, it would take 3 quintillion joules of energy. Now, just in case you can't even fathom that number, here are some different references to tell you what this means. Our brain uses about 12 joules every second, so for the average 79-year lifespan, your brain will use 29,896,128,000 joules of energy. Now, even though that is a huge amount of energy, that is only about 0.000001% of the amount we would need. The average house uses 37,454,400,000 joules in a year. Even though that is over 5 billion more joules than the brain, it still remains at the same percentage of 0.000001%, barely even making a dent in how much we need. Now, on average, New York uses 14 quadrillion 454 trillion joules of energy. This amount is obtained in 1 year of New York's power supply, and it is only 0.5% of the energy we would need. An orbital launch, the launch that sends satellites and stations into orbit around the Earth, uses around 30 million joules. This is only 0.00000001% of the amount we would need. Out of every single comparison I've made, this one caught me off guard the most because of how little it actually is. Finally, the sun. This is the only source out of every single comparison that I've made that would actually provide the right amount of energy to do this. The sun produces 386 septillion joules every single second. This is 12,675,823,224% of the energy we need every single second just from the sun. Now that we've talked a whole bunch about the energy we need, what about some problems that would come with this? Well, because of space, there are a whole bunch of problems. First off, the sun. As you can see, the sun produces so much energy that we could use it. However, how do we end up getting this? The sun is over 5,000 degrees Celsius and 1,392,680 kilometers wide. Harnessing the energy of the sun is near impossible to do with our current technology. Of course, there's things like solar panels, but to get the energy that we need directly from the sun is unfathomable. The amount of resources that wouldn't burn at the temperature of 5,000 degrees Celsius is extremely small, even if there is one, which there probably isn't. Not only that, but that temperature-resistant metal would be extremely rare and even more expensive. Now, the next big problem that comes with this is the speed. Light speed, while still being the fastest speed that we can think of and go, is still quite slow in this situation. Proxima Centauri is 4 light years away, basically meaning it is 4 years worth of traveling at the speed of light to get there. That is the closest star that isn't already our sun. Traveling within our solar system is good when it comes to light speed, but not traveling to distant stars or galaxies. Even traveling past our solar system would be semi-ineffective, let alone our entire galaxy. Finally, we'll talk about solutions. These solutions are near impossible and completely theoretical, but still offer some insight on what we might be able to do, but still not likely. First off is the sun problem. Harnessing this energy from the sun is near impossible, right? Yes, but I did say near impossible. The one small chance we have is to building a Dyson sphere. Dyson spheres are hypothetical spheres or nets, aka astronomically large structures surrounding the sun or a different star. Like I said, it doesn't have to be our star, the sun, but that would be the best idea for now, because Proxima Centauri is so far away from us. This structure would convert the power from the sun into energy we could use for ourselves. Dyson spheres being made over the sun would have terrible repercussions, but it would still be a way to get energy from the sun that we could use for travel. Even if that works, what about the speed of light? It would take years to travel anywhere, and since it's the fastest speed we can think of, doesn't deep space travel seem impossible? Well, I've still got one ace up my sleeve. A hypothetical theory that could save us. These are called wormholes. I did talk about them a very small amount in the last video about the multiverse, which you should totally check out. Wormholes are basically a shortcut to different points in space by traveling in two distant points of space-time. Creating one of these teleportation cheating exploits is very hard, and it would be extremely hard to accomplish ourselves. The amount of energy and resources it would take is huge, and it would take a lot, but it would still allow us to travel these distances much easier and much faster. Now, we have reached the end of this video. This topic is one that I really like and enjoyed researching about a lot. These kinds of topics really interest me, and they're the kinds of things that got me into wanting to learn about space as a whole. If you have any questions about anything I talked about in this video and any topic about it, please leave them in the comments. I will try and answer as many as I can. Please share this with as many people as you can if you did enjoy it. You can always like and subscribe, but that is not the main goal of this channel. All I want to do is educate and analyze all these things for you guys to watch as entertainment. I think in the next video I will either be talking about Ark Survival Evolved, a very underrated game, or Goldilocks Planets and the Goldilocks Zone. I'm not entirely sure though, so please leave them in the comments along with your questions about the topics I said in this video. Alright, I'll catch you all in the next one. Bye y'all.